Hey folks, this is Captain Jones here to talk to you about the overview of this course, EE375. I've got two objectives today, and that's to describe for you the course and the unit objectives to kind of get a broad picture of what we're going to do in this course, and then describe for you the lab assignments, or at least how much of them I've figured out at this point. I think those will give you a really good understanding of what sort of skills you'll gain in this course. All right, so to start, I want to say that EE375 is of course building off of our digital logic stuff that we learned in EE360, and kind of the arc of the whole course is to build off of that knowledge to get to the point where we can implement this computer called the LC3. Well, this computer is described entirely in Introduction to Computing Systems. And so that's the main textbook for this course. And even though the LC3 is kind of a fictional computer, it has many of the elements that make up modern day computers, like the ones you see on the right hand side here. You're probably most familiar with just a standard laptop. But part of this course is hopefully going to build up to understanding other slightly more specialized devices. So you can see here the Raspberry Pi, CircuitPython, Arduino. These are various microcontrollers and microprocessors that are used in lots of different engineering projects. And I have a desire for you to be familiar with them because I feel like you might actually end up using these devices in a capstone project or later on in your lives to kind of play around with. And I feel like one of the biggest ways this class can assist you is to help you understand what these devices are truly capable of and kind of how they operate. We're going to use, for part of the course, a second textbook here called Basic Computer Architecture. I'll show you a little later how to get access to that. And so if we kind of, I'm going to zoom out here just a little bit. I want to reiterate these three words right here. This is kind of, if I had to summarize the course objectives, right, in 3 words or 3 phrases, it's going to be that in this course, we're going to, number one, we're going to build a computer, a working computer, at least on our computers, at least in simulation, if not, in real life. Number 2, we're going to write programs for that computer that allow it to do useful things. Compute math functions or play games or interact with the user, those kinds of things. And then lastly, we're going to effectively compare the LC3 to other computers that I'll introduce to you. And in that way, we'll sort of get a perspective of the landscape of computer architecture and, sort of what differentiates the LC3 from these other computers you see here on the screen. The course itself is broken down into 7 units. You can see them numbered here 0 to 6. Unit 0 is one we're in right now. It's just the introduction to the course. So the purpose of this unit is just to get you familiar with the course format. It's probably kind of new to you, as well as the actual course material and the course policies. In the first unit, actually, you could probably say that kind of it's units kind of 1 through 4 that we spend building the computer, the LC3. So in Unit 1, we're going to sort of introduce this basic concepts of computing and start to layer on to what we know from EE360. And ultimately, we're going to build up to our first sort of basic working implementation of the LC3. And this is effectively discussed in Introduction to Computing Systems, chapters 1, 4, and 5. Once we have that, in Unit 2, we'll move on to introducing the idea of assembly language and how we can write programs in assembly language and start to make the LC3 that we built in Unit 1 do some useful things. In that unit also, we'll learn how the LC3 is able to implement some higher level constructs like function calls and a structure called a stack. And that's covered in Introduction to Computing Systems, chapters 6 through 8. In Unit 3, we're going to build off of the LC3 that we developed in Unit 1, and we're going to give it some really powerful features, notably the ability to talk to inputs and outputs. At the end of Unit 1, the most really that our LC3 can kind of do is, it can do some input and output stuff, but we sort of, we don't talk too much in depth about that. So in Unit 3, we'll go all the way down to the circuits. How does the LC3 talk to a display, write ASCII characters to a display, read ASCII characters from a keyboard, and additionally how it's able to implement higher level features like having privileged areas in memory that sort of start to implement some basic security features. Additionally, in Unit 3, once we have kind of these extra pieces of hardware under our belt, we can write slightly more complicated programs for that computer, for the LC3. In Unit 4, we're going to finish the construction of this device, which means predominantly we're gonna build the control unit that orchestrates this whole thing. So kind of, in units 1 through 3, we're building out this computer, but we're sort of assumed, that the control unit's been built already. In Unit 4, we are going to we're actually complete that control unit ourselves. And so you can see here a little picture of this, effectively the state machine, the finite state machine that is controlling this whole computer. And so that's covered in Introduction to Computing System Appendix C. And forgive me, Unit 3 down here, a little note, came from chapters 9 and 10. So at the end of Unit 4, we'll have fully completed the LC3. You'll have effectively seen, if not implemented yourself, all the way down to the circuit level, this entire computer that's able to do some pretty powerful things. In Unit 5, we are going to start talking about some performance improvements. And specifically, we're going to see how if we change the design of the LC3 slightly to introduce a concept called pipelining, we might be able to improve its performance and get more done in less time. To do that requires handling some very kind of sticky situations. So we'll go into how to make sure that we can complete that design correctly. Additionally, we're going to talk about the idea of a cache and how we can again improve the performance of the LC3 by introducing a cache next to our memory device. These are two really big improvements that occurred in the history of computer architecture that you see in basically every modern processor to this day. There's a little dashed line here from coming from this build objective, because although we're not gonna implement these things, the pipelining and the caches, at the level of detail that we've kind of previously implemented the LC3, we're going to use the LC3 as kind of like our example processor, and I'll show you in at least kind of block diagram fashion how we might add these performance improvements to the LC3. And then with any luck, we'll have time at the end of the semester to move on to Unit 6, where we talk about the differences between microcontrollers and microprocessors. And the LC3 is kind of the basics for both, but we use those terms to refer to different devices that are sort of take the basic ideas that we're going to have a firm grasp of at this point in the course that the LC3 demonstrates, and kind of optimize that for two very different scenarios. In so doing, you'll get an understanding of what kind of differentiates these computers up here and gets at that last course objective that I was talking about. That'll give you a kind of a grasp of what these devices are capable of, and which one maybe you should reach for when you're putting together a capstone project or a little hobby project later on in your West Point careers or just in your adult lives. Okay. The last thing, I almost forgot to mention are the labs. I kind of hinted at them briefly, but just to reiterate, so as you're going through the course, you'll get more details. In Unit 1, we've got a lab, and that's marked here with the little L. And that lab is going to be to basically implement the design of the LC3 that we'll have studied at that point in a digital logic simulator called Logisim. So you'll draw some circuits in your computer that implement the LC3. In Unit 2, we've got a lab, and the purpose of that is going to be to get some familiarity with assembly language programming. So this is a kind of a basic or a short snapshot of assembly language program. You'll write a slightly longer one in this lab to demonstrate your understanding of assembly language. In Unit 3, that's also where we write some programs. The lab here is going to be to either start a new program or build off the program you wrote in Unit 2 to be able to incorporate these input-output features or these high-level features that we introduce in Unit 3. So that's another one where we're kind of, we're writing software programs for the LC3. In Unit 4, your lab is going to be to implement that control unit, and I'll give you some of the circuitry. So basically, you're gonna be filling in a table to kind of implement this state diagram that you see a portion of here. That'll be lab number 4. Unit 5 doesn't necessarily have a lab. It's going to have something I think I'm going to call a recertification. So this is just a, it's going to look like an exam. It's not really an exam, but it's going to look like an exam that asks you questions pertaining to the first 5 units. And it's just a check to make sure that we haven't forgotten anything from the first few units. It'll look like an exam, like I said, because we'll probably do it in class. But it's one where if you get anything wrong, you'll get handed back, and you'll get the opportunity to correct those mistakes and turn the exam back in. And so, with no more than maybe a couple of rounds of edits, everyone should have 100%, just to make sure that we haven't forgotten anything. And then in Unit 6, we have our last lab. It's still to be determined because I'm in the process of kind of finalizing those or that unit. So more to follow on that. But in summary, this is our course. Hopefully by the end of this, whether or not you go on to take embedded systems development or you're going on to write programs and you never touch computer architecture again, hopefully this course teaches you some useful skills that help make the computers that you do use make a little more sense. That's all I got, folks. See you next time.